Welcome, dear students, to another very important topic of the chapter General Organic Chemistry, and that is the electromeric effect. Dear students, electromeric effect was once called as the tautomeric mechanism. Tautomeric mechanism is the old name of the electromeric effect. But nowadays, according to the recent recommendations of the IUPAC, the term electromeric effect and mesomeric effect both are becoming obsolete from the literature, and they are merged into a broader concept, that is the concept of resonance. So, dear students, the old name of electromeric effect is tautomeric mechanism, and now in the recent recommendations of the IUPAC, the term electromeric effect and mesomeric effect both are merged into the broader concept that is called as the resonance. So, in the latest publications, you will not see the terms electromeric effect or mesomeric effect. Rather, you will see a broader term, that is the resonance. My dear students, what is electromeric effect? Let us understand. Suppose we have a saturated hydrocarbon, that is ethane, in which there are all sigma bonds. If there is an attacking reagent, some electrophile or nucleophile in the reaction mixer with the ethane, then the ethane has all sigma bonds, and you know that the sigma electron density remains on the nuclear axis. So when the electric field of the attacking reagent, that might be an electrophile or nucleophile, interacts with these sigma electrons, there will be no effect on the sigma electron density, as the sigma electron density is present exactly on the nuclear axis, so it will be under the very strong nuclear force of attraction of the bonded atoms. So there will be no effect of the electric field of the attacking reagent on the sigma electron cloud. We will say that the molecule will remain unaffected. There will be no effect. But if we have some unsaturated molecule like ethene or ethyne that have pi bonds. Now, when electrophile or nucleophile, they will attack on the molecule of ethene or ethyne, then both of these they have pi bonds in between the carbon atoms, and you know the pi electronic cloud is present above and below the nuclear axis. So here again the pi electronic cloud that will be present above and below the nuclear axis. When the electric field of the attacking reagent will interact with the pi electronic cloud of these unsaturated molecules, then the pi electronic cloud gets disturbed and it is shifted to any one of the two bonded atoms. Here the two bonded atoms are same, so the electronic cloud, the pi electronic cloud can be shifted to any direction, either to this carbon or towards the other carbon atom. As a result, the two pi electrons are shifted to this carbon, so it will get positive charge and this will be negatively charged. In this case, the two pi electrons are shifted to this carbon, so it will get negative charge and that will become positive. Now, because of the shifting of the bonded pi electrons, you can see that an instantaneous dipole is created. This one is an instantaneous dipole which is formed under the influence of the attacking reagent, either electrophile or nucleophile, and same is the case here. But these are instantaneous dipoles, means these dipoles are created under the influence of the attacking reagent, and once you will remove the attacking reagent from the reaction mixer, then the instantaneous dipoles, they will be changed to their original form. So this conversion of the ethene into its dipole and the conversion of ethyne into its dipole is just because of the influence of this attacking reagent, and this is not a permanent conversion, this is a temporary conversion, and once you will remove the attacking reagent from the reaction mixer, both these instantaneous dipole will be changed back to their original state. Now we can define the electromeric effect. It means, first of all, before defining, you must know that for electromeric effect there are two conditions. There must be pi bond in the organic compound. Mean the organic compound should be unsaturated. In saturated organic compounds, electromeric effect is not observed. And second, there must be some attacking reagent in reaction mixer. And that attacking reagent can be either an electrophile or a nucleophile. So if both these conditions will be fulfilled, then you will observe the electromeric effect. In case if any of these conditions is not fulfilled, the electromeric effect cannot be observed. There must be pi bonds in the molecule. It is not necessary that those pi bonds should be conjugated, as that was the condition in the mesomeric effect. So electromeric effect and mesomeric effect, they are different from each other, because in mesomeric effect an unsaturated conjugated system is required, while in electromeric effect only pi bond should be present. The conjugation is not a condition. Now let us define the electromeric effect. Electromeric effect is basically the temporary polarization of an unsaturated organic compound due to shifting of shared pi electron pair towards one of bonded atoms under the influence of an attacking reagent, and that attacking reagent may be an electrophile or nucleophile. So this one is the definition of the electromeric effect. It is a temporary effect. It is not permanent like the mesomeric effect. It is the temporary effect in which polarization of an unsaturated molecule takes place. The unsaturated molecule is changed to the dipole. Due to shifting of pi electrons towards one of the bonded atoms, and this shifting of pi electrons is due to the influence of the electric field of the attacking reagent, that may be a electrophile or nucleophile. Now, my dear students, electromeric effect is of two types: positive electromeric effect and negative electromeric effect. In case of positive electromeric effect, just look at the example in which ethene is protonated. H positive is the attacking reagent, which is basically an electrophile. So the first condition of the positive electromeric effect is that the attacking reagent should be an electrophile. So the attacking reagent should be an electrophile. This is the first condition for the positive electromeric effect. Now what will happen? Under the influence of this attacking reagent, the pi electron pair will be shifted to any of these two carbon atoms. As a result, a temporary dipole is generated. Now, my dear students, this H positive that will be obviously attracted towards the negative carbon. So you will say that the H positive will attack on the electrophile will attack on the negative end of the dipole. As a result, this carbocation is produced. It means the first condition was reagent should be an electrophile. The second condition is that this electrophile will attack on the negative end of the dipole. And the third one is that this reagent, which is an electrophile, will be attached to the negative part of the dipole. You can say that this electrophile or the attacking reagent will attach to that atom which has gained the shared pi electron pair. And obviously, if this carbon atom gains the shared pi electron pair and it becomes negative, then finally the shared electronic pair that will move to the electrophile which is electron deficient. So the first point for the positive electromeric effect is the reagent should be an electrophile. The second one, the reagent will be attached to that atom which has gained the pi electron pair. And finally, when it will attach to the negative atom, the pi electron pair will finally given to the attacking reagent. So the attacking reagent will get the pi electron pair at the end. This was the positive electromeric effect. On the other hand, the second one is the negative electromeric effect. Now, my dear students, in case of negative electromeric effect, the reagent should be a nucleophile. For example, if there is a carbonyl compound and a nucleophile attacks on it, no, this one is partial positive, partial negative, and pi bond is present between them. My dear students, in the previous cases that we have discussed so far, the pi bond was present between two same atoms. But in this particular case, the pi bond is present between two different atoms. So here, the pi bond could be shifted to any of the two bonded atoms. But in this case, the two atoms are different. So we will have to decide the direction of the shifting of the pi electron pair. Now, in which direction the pi electron pair will be shifted? Because the carbon is less electronegative, oxygen is more electronegative. So it is a common sense that the pi electron pair should be shifted towards the more electronegative atom. In this case, the pi electron pair will be shifted to oxygen. You cannot shift the pi electron pair towards the carbon. As a result, you will get C single bond O, it will become positive, it will become negative. Now the attacking reagent will not attack on the negative part of the dipole, just we have seen in the case of the positive electromeric effect. Rather, the attacking reagent will attack on the positive part of the dipole. And what will happen? It will be attached to this carbon and the pi electron has moved away from this attacking reagent. So the attacking reagent is a nucleophile. It attacks on the atom which has lost the shared pi electrons, and now the shared pi electrons, they have moved away from this attacking reagent, and the shared pair of the pi electrons that is not finally given to the attacking reagent. In this case, the attacking reagent is away from that shared pair of electrons because the shared pair of electrons were shifted to oxygen, but the attacking reagent is attached to the carbon atom. So in positive electromeric effect, the pi electron pair is finally given to the reagent. But in case of negative electromeric effect, the pi electron pair is not given to the reagent, rather it moves away from the reagent. So that was the negative electromeric effect. Now, my dear students, the electromeric effect is different from mesomeric effect in the sense that in mesomeric effect conjugation is condition. In electromeric effect the compound should be just unsaturated, and it is not necessary that it should be conjugated. And secondly, electromeric effect is temporary, mesomeric effect is a permanent effect basically. And what is the difference between electromeric effect and inductive effect? So dear students, keep in mind that electromeric effect can take place between two same atoms with no electronegativity difference. But in case of inductive effect, the bond should be between two different atoms with some specific electronegativity difference. I have already delivered a lecture about the mesomeric effect as well as the inductive effect. The link of the lectures will be given in the description of this video lecture. I hope so that this lecture will be useful for you people. In case you find any problem, there is any query in your mind, you can ask in the comment section. We will come up with some new lecture next time. Till then, take care.